Hi everybody, this video is going to discuss friction. By the end of this, students will be able to identify and define the factors related to frictional forces. Here's Audie. That's Lily mumbling in the background. So friction is the force resisting the motion between two surfaces. The larger the force of friction, the harder it is for the surfaces to move. For example, if you try rubbing two sheets of sandpaper together, that would create a large frictional force, whereas walking on ice creates a small frictional force. Ice is very slippery, so it's easy for the things to move across those surfaces. The equation for friction is this FF, which stands for the force of friction, equals this letter called mu times Fn. FF is the force of friction measured in newtons because it's a force and all forces are measured in newtons. That weird letter is Greek letter mu. It stands for the coefficient of friction. It's kind of like a U with an extra piece in the front. It's a Greek letter. And F with the subcapital N, Fn, stands for normal force, not net force, which is also measured in newtons. Can I show everybody your picture? Yeah. Here's her picture. And she fell on the ground. Are you okay? Do you want to say hi? Yeah, say hi.
Hi.
All right, so the normal force, or Fn, is the perpendicular force from a surface, so like perpendicular 90 degrees, that balances an object's weight. So if you're sitting in a chair right now, then the normal force is the chair pushing back up on you with your weight pushing down. Okay.
Hi.
The normal force is a reaction force as stated in Newton's third law of motion. You know, for every action, there's an equal and opposite reaction. Since the normal force is always equal and opposite to the object's weight, we can calculate it by using mg, or mass times the acceleration of gravity. Okay.
Hi.
So mu is the Greek letter I mentioned earlier. It's pronounced mu, like M-Y-O-O, like it rhymes with stew. It always has a value between 0 and 1. It'll always be a decimal. Hold on. It describes the amount of interaction between the two surfaces. The greater this coefficient, the more resistance there is between the surfaces. Mu has no units. It's simply the ratio between the force of friction and the normal force. To determine mu, you need to measure the force of friction and the normal force, then divide them. And we're going to use that equation. We're going to do this in the next lab. Time for a challenge question. If you pull an object with a force so that the object moves with constant velocity, is that pulling force less than, equal to, or greater than the force of friction between the object and the surface? If you said greater, then you are entirely wrong. That's not correct at all. They're going to be equal, since if you're pulling with a constant velocity, there's no acceleration. So whatever you're pulling with has to equal the other way's force. So the pulling force equals the force of friction. That's it for this video. Okay. That's it for this video. Thanks for watching. Thanks for dealing with my kids. Make sure to answer the friction video questions in Schoology and bring your notes with you to class because you'll need them.